Assalamu alaikum. Bismillahir Rahmanir Rahim. In the name of Allah, the most beneficent and the most merciful. Guys, today's lecture is very important lecture, right? Because now we are going to explain about the combination of functions, right? Is how will you combine two functions, and then you have to find the domain. This is very important, and such type of questions has been asked in many global exams, right? So this is very hard and complicated, and most of the students get confused on that questions. How to find the domain of combined functions means if you have two functions and you are going to combine it, right? Either by any operators, positive, negative, or multiply or division, whatever, and then you have to find the domain of that one. Okay, so we have two functions. One may be trigonometric functions, one may be linear functions, one may be quadratic functions, okay, algebraic functions, exponential function, logarithmic functions, inverse function, anything, right? You have two functions and these functions are combined, right? And then you have to find the domain. This is very important. So I'm going to explain you, whenever you see two functions and they are combined with each other, then how will you find the domain of such functions? Okay guys, so for example here, domain of, I'm going to write down the heading, domain of combined function, COMBINED, combined. Domain of combined function, right? Combined function. You are going to combine something. Domain of combined function, right? Okay. For example, I have fx, right? And this fx is under root x. And I have another function which is what? Gx, which is 1 minus x. Again, I already explained you about a square root function in my previous lecture, and we have given a lot of questions and solved domain, right? But here we have two functions at a time, fx and gx. Fx is under root x and gx is under root 1 minus x. And the question is, find the domain find the domain okay. So I'm going to write down some combined function here. Find the domain. The first one, you can say we have fx plus gx, right? We can also say find the domain of fx minus gx. We can also say find the domain of what? Fx multiplied by gx. We can also say find the domain of fx divided by gx, right? Means we can just add them, subtract them, multiply them, and divide them, right? So if we have, this is also can be written as f plus g x. This can be written as f minus g x. This can be written as f g x, and this can be written as f divided by g x. Now the question is, you have to find the domain of this one, right? Okay. Remember, if you are going to find out domain of this one of any combined functions, you must know what is the domain of this one and what is the domain of this one, right? Once you know the domain of this one and the domain of this one, we will take the common part, right? We will take the common part of this one. This is very important. Very important. We will take the common part of this one and this one, the common domain of this one and this one. I am going to solve these two questions here by graph. As I told you before, if you have fx which is under root x, you know the graph of under root x, I told you in my previous lecture, this is always what? All positive values of x. The domain here, I'm going to write down here domain, D for domain, which is what? 0 or greater than 0. Means all positive values of x included with 0, right? And when we talk about, we have another function which is gx. Okay, this is very important, which is under root 1 minus x. Do you remember? I told you how to find the domain of this one, right? As you see here, this is minus 1, means this can be written as, please watch my previous lecture, so you will find this one. 1 minus x can be written as minus x plus 1. And I told you, whenever you see minus x, the graph will be in this direction, right? And how will you find the next? So as you see, this is plus 1, you have to find from minus infinity to minus. You have to take the y-intercept and the coefficient of x, which is minus 1, to find the domain. And here you have to use this bracket. Here you have to use this one, right? So minus infinity, minus minus plus 1. So you can say the domain of gx from minus infinity to 1. So you can say this is 1 is here, right? And minus infinity, because this is minus x, so graph will be always like this one. Okay, so this is the graph of what? You can say under root minus x plus 1, and this is the graph of under root x, right? So can you tell me that which part is the common here? This means all positive values of x, all 0, 0.1, 0.2, 0.3 to all positive infinity. And this means minus infinity to 1. So you will say the common part is this one. This is the common part. This is the common part, right? You can say the common area of common part. A common domain. Common domain. What is the common domain? From 0 to 1. And I'm going to write down the close bracket. 0 to 1 comes here also. You can check, this is the domain of this part, as well as this is the domain of this part also. From minus infinity to 1, it includes 0 to 1, right? So the domain of this function, the domain of this function, the domain, D for domain of this function is 0 to 1. And please note it that we are going to use the close bracket here, 0 to 1, right? So if you have fx plus gx or gx plus f, it doesn't matter. If you have fx plus gx or gx plus fx, if you are going to combine, the domain will be 0 to 1. So when you draw this graph, okay, you will find the graph will be from 0 to 1 only. Only from 0 to 1, okay? So the graph of this one and this one is not for all the real number. No, the graph of this one is drawn from 0 to 1 only. And this is also the domain of gx plus fx. It doesn't matter, right? And you have to use what? Close bracket, 0 to 1, right? Okay. And if you are going to subtract the same things, the domain will be the same. The common part, 0 to 1, and use the close bracket, right? For fx minus gx or gx minus fx, doesn't matter, the domain is 0, 1. Again, we are going to take the intersection part of the domain, okay? And even if you are going to multiply them, no problem, the domain would be the same, 0 to 1, and you have to use what? Close bracket, 0 to 1, okay? Whenever you are going to draw under root x plus under root 1 minus x, or under root x minus under root 1 minus x, or under root x multiplied by under root 1 minus x, you will see the graph drawn from 0 to 1 only, right? And the last one that you have to note, okay, this is important part. There will be a slightly change here, guys. As you can see, the function gx are in denominator, right? And if you have any rational function and the denominator is 0, the function does not exist, right? So what is the gx here for this one? Means the question would be like this one. Please have a look on that. This is important. what you have to do only, fx is what? Under root x. And what is gx? Which is under root 1 minus x, right? So as you can see, this one, this denominator, this one, can you see this one here? Only here, only this value, and I told you the graph of this one here. You can see this minus x is here and 1 is here, right? So the domain for this one, okay, is from minus infinity to 1, right? As I told you. So it's very simple question, very simple question. And this one, under root 1 minus x, this one, see the denominator, you can say 1 minus x. This cannot be a 0 if you make a square on the both side. So you can say square and 0 square. So this is 1 minus x, this is equal to 0. So x is equal to 1. Means according to this one here, I'm not talking about just only this one, I'm talking about here in this function, in this combined function. Here the domain set, you have to take 1, but when we take 1, the function does not exist, because if you put 1 here, 1 minus 1, 0. So under root x divided by 0, the function does not exist, right? So we will say in this case, only in this case, the domain will be minus infinity to 1, but we are not going to include 1, we are going to exclude 1. So use the open bracket here and open bracket here. So only this one. The domains are drawn, sorry, the graph are drawn only this domain, but we are not going to include 1 here. Like here, 1 is included, 1 is included, 1 is included. Here, if I say the domain is 0 to 1, right? For this one, right? Okay. So if I say, because the domain will be the same, right? If I say 0 to 1, so 1 is included, but when you put here 1, the function does not exist. So only what you have to do, erase this part, and you have to use this bracket only. Don't take 1. The domain will be the same, only don't take 1 here, because if you put 1 here, the function does not exist. So this is what 0 to 1, and again and again and again I said to you, the domain will be the intersection part of both functions, right? And for example here, if we are going to change the function, for example, okay, or if we say we have a function gx divided by fx, for example, for a while, so you can say this is g divided by f and this is x. What is the domain here? So again I will say the domain will be the same, 0 to 1, but just wait for a minute. Okay, so now here I'm going to write down this one, and you have to check only this part. So as you can see, we have gx. What is gx here? Under root, we are going to find gx divided by fx, right? So under root x, gx is 1 minus x, and fx is what? Under root x. Can you see this one? And here, if you see, this is a rational function. So where x is not equal to 0, because if you put x is equal to 0 here, the function does not exist. For each and every value of x, the function exists except 0. But here, according to this one, 0 is included. If we include 0 here, the function does not exist. So what you have to do, just erase this part, okay, erase this part, and use the open bracket only. Okay, so this is the domain of this function. Okay, the domain is the common here. Look, in addition, subtraction and multiplication, we will take the intersection part of the domain. But if you have any function which is written in rational form, so what you have to do, you have to understand the end points. Sometimes we are going to take this value and the function does not exist. So you have to check only the brackets. We are going to use the open bracket or the closed bracket. So here 1 is not included and here 0 is not included, right? And these are the domain of combined function. Guys, please watch my next video, because where we are going to solve 3 or 4 questions of combined functions, and we will ask you how to find the domain, and it would be so easy if you understand all this concept. I hope guys you all understand. Please take care. Assalamu alaikum.